cloud security concepts, trying to keep it, intermediate, entry level to intermediate level. And show you guys some new tools I've written that might be of help. All right, introduction. So I am Bryce Kunz. My handle on Twitter is TweakFox, and I'm famous for wearing Hawaiian shirts apparently. That's why I have this picture of me wearing a Hawaiian shirt on Twitter that Troy was nice enough to get created for me. I used to work at Homeland, so I ran incident response and focus operations there, which is like hunting down APTs and getting them out of the unclassified network. And then I worked up at NSA. I was over an offensive unit responsible for collecting more information about APTs. So I was doing a lot of red teaming type stuff there. And then I built out a red team for Adobe's digital experience unit here in Lehigh, and then I started doing stage 2 security full-time a number of years ago. We're a boutique cybersecurity shop. We're just over 60 employees now, and we have kind of a group that just focuses on delivering penetration testing and red teaming, type services for clients, specifically in cloud environments like AWS, Azure, GCP, as well as for applications like web apps or mobile apps or like IoT devices and things like that. So we won a number of awards, as well as I'm the president over the charity that runs B-Side Salt Lake City, those events, so we're hoping to get those back online pretty soon. So cloud security has a number of challenges, and this is really where I'm focusing most of my time. I teach a class at Black Hat where we just talk about red teaming in the cloud providers, getting access and expanding access, and a couple of the guys at Stage 2 help teach that as well. And so really, we're trying to come up with ways at Stage 2 how to scale the operation. So we kind of built this microservice platform where we kind of automate a lot of our red teaming services, which if you're interested in talking more about, come up and talk to me afterwards. But today, really, we're going to be talking about cloud security and some pretty easy stuff you can do and get high impact results. So I just want to be clear, there's been a lot of research in this area in the past. So I tried to list some of that on the right side of this slide. And then on the left side is kind of the new contributions that I'm making as part of this talk. Namely, I've written some scripts and I've pushed them to GitHub. So you're welcome to check those out, and I'll be talking more about those as I go through the talk today. So I know this is pretty basic stuff, but I just want to make sure we're all on the same page, right? So when you use AWS, you're using on-demand services. And one of the main services that people use there is EC2, right? Elastic Compute. And this is just basically allows you to stand up virtual servers as a service, or like VMs as a service inside of Amazon's cloud. So those VMs, they need a way to store data. So largely the VMs store data using a technology called Elastic Block Storage, or EBS. And it's really just a storage service that's designed to create disks, kind of like if you're acquainted with like VMDK files in VMware. It's kind of equivalent to that, but meant for AWS's EC2 VM technology. And so you have these EBS volumes, and then you'll attach those to the instances, and that's kind of where the operating system and data is going to be stored persistently. So they have this feature in the platform where you can create a snapshot. So when you have a disk, anything that gets written to the hard disk, you can create a point-in-time copy of that, and that's called an EBS snapshot. And they have a feature there where you can create incremental backups. So you can figure out what was saved in the last snapshot and just save the differences between the two to save you space and make the snapshotting process more efficient. And then they have features where you can share those snapshots with other AWS accounts. And they do that by you reference, every AWS account has its own unique account ID number. So you can reference another account ID number, or you can just share it globally. And if you share it globally, that's what I'm going to be talking about next. But yeah, you can specify an account ID or share it globally. So here's what it looks like when you're inside the console. If you have an EBS snapshot, by default they're set to private, but there's just a radio button there that you can set it to public, or you can set to private, but then specify another AWS account number if you just want to share it with a limited number of accounts. So if you flip it over to public, that means basically anybody in any AWS account can pull a copy of that snapshot. Snapshots are region constrained. So what's a region in AWS? That's like a logical area. Usually it consists of a few data centers that are kind of linked together on like a metropolitan network, like geographically pretty close. But from your standpoint, you kind of pick a region, like you pick Northern Virginia, or you pick Oregon, right? And they have a data center, what looks like one data center to you as a user. And when you share EBS snapshots publicly, you can only share them unencrypted. So there's no encryption that could protect you once you're sharing an EBS snapshot publicly. Okay, so an account ID. If you caught my talk last year, I talked a little bit about this, and I'll just kind of give you the TLDR on that. But basically, when you register for an AWS account, you're going to get this 12-digit number. It's going to be unique for your AWS account. It's semi-sensitive, like there's really no way for you to look up what somebody else's account ID number is. So it's kind of private, but it's not super private. So you can get account ID numbers. Like for example, let's say you find a vulnerability in an application running inside a Lambda function. There's like a certain directory you can query there to pull out the AWS account ID number that's being used. You can also grab account ID numbers from some other techniques we'll talk about. But once you have an account ID number of a targeted organization's AWS account, you can kind of guess role names inside of IAM, and you can see based on the responses whether those role names exist. So there's common role names for services like Okta and Datadog and CloudSploit and all that. So ways you can get an account ID is one of the ways is from these public resources. So when you share out your EBS snapshot publicly, that will also include your account ID number associated with it. So that's another way that account ID number could be disclosed. In and of itself, it's not horrible, but if you had a role and the role name was guessable, there's a possibility that under certain contexts, an attacker could gain access into your AWS account. But it's kind of a rare edge case. Another way is just by putting the account ID number and this URL. If you get back a 404, then you know that account ID number doesn't exist. If you put it in and you get a 302 error back on the HTTP GET request, then you know the account ID number does exist. So last year I showed you how you could build a SAM application, and also I did a workshop on this yesterday. But basically, AWS has this serverless application model, and it's a way that you can define in a small template a serverless application. And what it really is going to do is it's going to take that template and it's going to expand it into a full CloudFormation template that's going to be much larger, and then it's going to push that off to the CloudFormation service. That CloudFormation service is responsible for basically doing infrastructure as code, or it takes whatever you define in that YAML file and deploys and creates that infrastructure in AWS. So SAM helps us do that more easily. And I kind of create these inside the Cloud9 IDE, which is a browser-based IDE inside the AWS ecosystem. That's pretty slick. So we can define in SAM an API gateway, and then from there, the API gateway can send data to a Lambda function, and data can kind of chain through from the API gateway to the Lambda function. The Lambda function can process it and send back the data to the API gateway. Okay, so last year at SAINTCON, I kind of showed how we could build a basic SAM app, and that SAM app had one API gateway which would send data to a Lambda function, and what that Lambda function would do is it would try and hit the gateway, this gateway here, and it would create a random ID number, and it would hit the gateway, and it would look at the response, and if it got a 302, it'd write it off to an S3 bucket, and then it would just keep doing that repeatedly. So in this way, I was kind of using AWS's Lambda service to kind of enumerate valid account ID numbers. So there's the video from it last year, which goes into more depth. Okay, but an easier way to get account ID numbers, right, is obviously like that's included with data that's being shared as part of this EBS Snapshot service. So if you have an instance and that has a volume attached to it, and then you create a snapshot of that, and then you share that publicly, the account ID number that did that is going to be also shared publicly. So I just wrote a quick Python script that uses the Bato 3 SDK, which is like AWS's Python SDK for interacting with services. And what that is going to do is it's going to connect to AWS, it's going to get a list of all the current regions, and then it's going to go into every region and it's going to pull out certain data about EBS snapshots that are shared publicly in that region and kind of create a list of it. In that list, it's going to have the snapshot ID as well as the account ID number associated with that EBS snapshot. So here you can kind of see that the first item in the list is the account ID number, and then the second one is the snapshot ID number. And then it's going to kind of generate a file per region because it's going to iterate through each region that is available in AWS. And there's the script. It's up on GitHub, so that might be of help. Okay, but there's a little bit more data that can be extracted from the metadata associated with a snapshot. So when a snapshot's created, there's some metadata created with it. There's not a ton of data there, but there is some that might be of use. So I wrote another script, and it dumps all the metadata into JSON format rather than kind of that list format. And that's also up on the GitHub page right now. And it's going to do something similar, like create a file per region. That's going to be a JSON file. And then you can kind of search through those files that have the metadata for things that might be of interest. Like you can see in the next screenshot, I just grepped for the word private, and you can kind of see some of the snapshots come back and they reference being created from a private directory. So there is some more interesting data here if you do this on your own. I just put something pretty benign here in the screenshot. But I'll leave that up to you guys. So, okay. And once again, by design, none of the data in the EBS snapshots are encrypted, right? So there's nothing stopping you from pulling the data. Okay, if you want to get a little bit deeper with the mining of the data, because right now we're just talking about searching through the metadata and the account IDs. There was a talk 2 years ago at Defcon that I referenced in this slide, and he created this tool called DuffleBag, and it creates an elastic bean application which attempts to mine the actual data inside the snapshots for like private keys or other secrets, things like that. So transparently, I got the application to compile after some modifications, and I deployed it, but I didn't really have much luck finding anything using his code. With that being said, it probably, it's 2 years out of date now, so it probably just needs some more modifications. Once you find an EBS snapshot that you're really interested in, there's a cool feature in AWS that I want to make you guys aware of, where you can download the EBS snapshot contents directly. So normally, let's say you find a snapshot and it's interesting, right? You can pull that into your AWS account, then you can create a volume from it, and then you can create an EC2 instance, and then you can mount that volume that you got created from the snapshot. And then if you know the file type, like this is NTFS or this is EXX3 or ETX3 or whatever, you can kind of mount it and start browsing the files, right? But a slicker way to do that, in my opinion, is, so remember how I talked about originally that you could take snapshots, but then you could also take like an incremental snapshot? Well, it became to the point where people didn't want to download the entire snapshot image because those are getting really large. So basically, AWS came up with these direct download APIs for EBS snapshots, where you could actually specify offsets inside of the snapshots or portions of the snapshots, and you could just download the portions directly into kind of like a DD type image of the snapshot. And AWS Labs has a tool to do this called ColdSnap. I didn't have a lot of success with the tool, albeit it should work. I had issues getting it to work personally. So, but it supposedly will download an image of the snapshots. So because I didn't really have a lot of luck with the AWS provided tool, I wrote my own tool to do that, which I pushed up to the GitHub repo. And this is going to show you how you can just use the Bato3 Python SDKs to download the raw contents into a DD image file, which then you can mount using standard tools in Linux. So you can see here, you run the script kind of with the parameters. You specify the right region, because remember, snapshots are region locked, and then the snapshot ID. And then when it's downloading, you'll see a .temp file. When that completes, the script just flips that over to a .done file. And then you can mount that using standard Linux tools. OK, so I pushed that up to the repo, so that's available now too. OK, cool. All right. So there's a lot of other services where you can do something really similar. So I just want to talk about them briefly. So on AMIs, what is an AMI? That's like an image of an instance. So before with an EBS snapshot, that's kind of an image of just the disk, the hard disk, where an AMI is an image of all the information relating to the VM. So it's more incumbent. You can also share AMIs publicly. You can see here in the console. If you go to AMIs, you can see the public images. Remember, they're locked in that region, so you need to browse each region to kind of get a list of what's available. And this is what it kind of looks like when you're in the AWS console. So you can see other people's AMIs that they've shared out. And you could take a similar approach to kind of cloning the AMIs, standing up instances, mounting the disk, and ripping out private contents of those. So that's pretty similar. Our RDS also has a snapshotting type feature. RDS is the relational database service in AWS. You can create snapshots of your RDS databases, and that's very similar to those EBS snapshots. So those also can be made public across, like globally across all the AWS accounts. So then you can pull those into your AWS account and start analyzing them. So here's kind of a list of the ones that are shared in the Ireland region, at least some of them. Okay, and then Scott has a great list up on his GitHub repo of other services where resources can be shared publicly. So I have a reference to that in this slide. And so there's definitely, like I've definitely been on engagements where we've done audits of AWS environments and seen SNS queues and SQS queues, where if you have the right information, they're completely public, right, to read or publish messages into the queues. Okay, cool. All right. So the technique for mining each of these, you'd have to research each service and then figure out how to kind of clone the data into your AWS account and then mine through it. So a lot more work here to be done if you wanted to kind of do something more comprehensive. All right. So that, I don't want to like, I don't want to go too overboard on that. So I just wanted to kind of make you guys aware of that and talk about the general techniques an attacker would use to kind of get initial access into other people's AWS accounts. One thing that I just want to make you guys aware of that we found pretty useful at Stage 2 security on our deeper red team engagements is leveraging kind of the cloud redirection features in AWS and Azure. So we've kind of built our own toolkit that we use to chain agents together to get deep in networks on red teaming engagements that we call VooDoo. And let me just take a scenario, right, where we exploit into a web app. It's like in a public network, and we come in through the firewall and exploit the web app that's available on the internet. And then we'll like install the VooDoo agent and get a callback, and then our operators are able to operate on that. And from there, they try and expand access onto other systems inside the private network or VPC, and they try to move around and get to the real target, the place that has the data, right? So where we typically get caught in these engagements is not when we're moving around on the internal, because that east-west traffic is sometimes a lot less monitored. We typically get caught on the callbacks where it egresses out to the internet, right? And the reason for that is because you run into things like, domain reputation for the callback or information associated with the TLS certificates that are associated with the attacker infrastructure, or just generally kind of like the timing or cadence of the callbacks looks weird or abnormal to the environment. There is a community edition for VooDoo, so if you want to, you can go to the website and check that out. Or if you have any questions, feel free to hit me up. I'm happy to help. I created an intro video that's up on YouTube if you want to check that out more. So how do the cloud services really enable us to solve this? Well, if we use a service like API Gateway, so API Gateway is kind of like a reverse proxy service in the cloud, right? It's going to set up like a REST API and then just forward data back to other AWS services, or even just any server you specify. So you can have an API Gateway forward data back to a server sitting in DigitalOcean. That's totally valid and within the use cases. But the cool part is when you create an API Gateway, it will by default use AWS's valid TLS certs. It will also use their, it'll give you a valid domain, right? So you can kind of use that for callbacks from the agent and then forward that data on to the VooDoo LP or whatever you're using for C2. So here we can see kind of just redirecting the comms through the AWS services. And I posted up a script that's at the bottom of this slide on how to do that. If you guys are interested in checking it out more, it'll automatically set up this API gateway to any server you specify. Okay, and then I've talked a little bit before about logging disruption, but I just wanted to bring this up in case you haven't seen it. But inside of AWS, the main mechanism for detections is this CloudTrail service. And the easiest way to set it up is you can configure CloudTrail, which anytime someone hits any AWS API, it'll create a log. And so you can create it so that it will output logs to an S3 bucket. But the kind of kicker here is that the CloudTrail service will actually buffer the logs before it writes it to the S3 bucket, because it doesn't want to be writing to the S3 bucket too much. So let's say an attacker, they get access to your AWS environment because they've been mining EBS snapshots and they found like some secrets that were stored inside an EBS snapshot. Then they start interacting with your AWS account, but you have CloudTrail enabled, right? So CloudTrail is going to record exactly what that account is doing. Those actions are going to get buffered and then eventually written into the S3 bucket. So if the attacker gains the rights to modify the CloudTrail service, he may be able to kind of muck with this, and I'll show you how. So in this scenario, he's got credentials via mining EBS snapshots. He's interacting with the target AWS account. It's generating logs that are suspicious. Those are going to a system like Splunk or another log aggregation system, and then the attacker kind of gets caught, right? So like let's say he goes in and he tries to delete the trail. Well, that's going to create a delete trail event. That's going to go in the buffer. Eventually, they get written to the S3 bucket. And maybe when it gets written to the S3 bucket, that gets picked up and then put into a Splunk cluster. And then it gets detected by the SOC, and the attacker gets busted, right? So attackers don't really like getting busted. So there's a technique and where an attacker, he can issue the delete trail API call. And then immediately after that, what he does is he does a create trail API call. And he creates basically the exact same trail that was just deleted. But this time, he actually specifies a different S3 bucket. He specifies an S3 bucket that's in an attacker-owned AWS account. And what happens in this is CloudTrail sees the delete trail message. It buffers it because it doesn't want to write it to the S3 bucket immediately. But then we create the trail, but we change the S3 bucket to the attacker-owned S3 bucket. And when the buffer or timer gets hit, CloudTrail pushes the delete trail message to the attacker-owned bucket, and then the SOC or the detection team actually never gets alerted because they never got the delete trail event because it was sitting in that kind of in-between zone. Now the attacker obviously could process those logs, remove the delete trail events, and then if they have access, send them back to the target's AWS S3 bucket. But that's a little bit more work. And I created a full video on this and pushed that up to YouTube a while ago. So if you want a more in-depth, feel free to check that out or come talk to me more. There's ways you could avoid this, but I'm just talking about that kind of default setup where you're pushing it to the S3 bucket. Okay, conclusion. I know this wasn't a very long talk, but I think we're the last one of the day, so it should be good. Cloud security is pretty complex. There's a lot of issues there. We've kind of built a platform to deliver more continuous services on the red teaming and pen testing side. But the long story short is you really need to get into your AWS, your Azure, your GCP, your cloud accounts, understand them at a deep level, understand what's going on in them, how they're secured, and focus there as more and more companies become cloud first, right? More and more data is getting pushed to those environments, and more risk of attackers getting to it is relevant. So if you have any questions, I'll be up here. I did push this slide deck up to speaker deck, so it's already there. The code is on GitHub in that Capture the Cloud. There's a directory called mining, and that's where I push the bulk of the code for this talk. And we teach a training that's a 4-day training on just all about red teaming inside AWS, Azure, and GCP to companies as well as at Black Hat. So if you're interested, hit us up about that. So thank you guys for taking time out of your day to come down. I appreciate it. And that's the talk. So thanks.